How's everybody doing? Hey, I'm on page 40. Page 40, right there. You see that? Page 40 down here. Okay. Page 40 in book 2. Okay, let's get started. So it says matching a story with its graph. Okay, let's try and do that. Here's the stories on this side, and here's the graphs on this side. Okay, let's try it. Try the first ones. Kiahi started walking slowly to work, knowing he had given himself plenty of time to get there. But after stopping to talk to a friend along the way, he realized that he was late and ran to make it to work on time. Now, which of these graphs would describe his actions over here? Okay, so we look at the timelines and we look at the distance. The distance is the vertical line, time is the horizontal. So, which one would that be? He started walking slowly to work, knowing he had given himself plenty of time to get there. But after stopping, so when it says stopping, you know that the distance is not going to change. So when he stops, it's either going to be like a horizontal line like that or like that. He ran home to make it on time. So he started walking slowly. It looks like it's going to be this one here. No? Okay, stop. Or could be this one, or this one. Because it has that stop characteristic of the line where the distance doesn't change, but the time goes on. So he walked slowly first and then ran home to make it on time. So let's see. Not ran home, I'm sorry. Ran to work. So he ran farther from his house. So he didn't come back home like this one. This one, he came back home. This one, he kept on going to work. So I think it's this one right here. So let's call this number 1. Okay. Okay. Number 2. Okay. Can you see that? Okay. Not wanting to be late for school, Kiahi left his house running in an attempt to make it to the bus stop on time. After waiting for a few minutes at the bus stop, he realized it was Saturday and walked back home. Now, which one would describe that story? Okay. He ran first, so he went fast, like this one maybe, or maybe this one. After waiting for a few minutes at the bus stop, here's another one waiting again. He's waiting. So he ran and he started waiting and then walked back home nonchalantly. I believe is this one right here. Okay. We're going to label that. Okay. I believe that's the one. How about number 3? Kiahi went out to climb the hill behind his house. He climbed slowly up the hill, walked quickly across the top, and ran joyfully down the other side. So when he went slow, then he went faster, then he went fastest, right? So there's only one graph that has those 3 characteristics while still going away from his house, which is this one, G. Let's mark that. Okay, number 4. After spending a day at the beach, Kiahi walked slowly back to his house at the same rate the whole way. So it starts at the beach. So it doesn't start from zero at his house. Like this one, this one, this one. It starts away from the house. And he walked the same rate, so it's the same slope. So it's just one straight line slope. You see how slope is like that? One straight line. It's a linear function, right? Okay. So H, I believe that's H, number 4. Let's mark that. Okay. Number 5. Take a look at that. Kyahi set out to walk his dog to the park. Halfway to the park, he realized that he had left his dog at home. Okay, that's hard to believe. After going back home to get his dog, they ran to the park together. So if he went back home, he would have had to go back to zero distance. So which charts would give us that description? Okay. There's only one chart here, is this one right here. It goes back to zero distance. And when he got back home and picked up his dog, they ran to the park. So it's a steep incline. Okay, they ran. So I believe number 5 is B. This one right here. Let's mark it. Oh. Okay. Number 6. Kyahi walked his friend's house, hung out a while, and then ran home just in time for dinner. Walk, so it's a slow walk. Hung out at the friend's house, then ran home for dinner. I believe it's something like this. Hung out means he didn't change his distance from home, so it would have to be a flat horizontal line like this. Okay. So he walked. Okay, check this out. He walked, stayed at his house, and then ran home. This area, so he did come back home, and it's a steep incline because he ran. He didn't walk like over here. You guys see the difference? Okay, I hope you can. So for this one, I'm going to mark it as number 6. Okay, what else do we have here? We have 2 more, yeah? Okay. Number 7. Kyahi set out walking to meet his friend at the movies. When he got there halfway, he realized that he left his wallet at home and started walking back. But then found $20 in his pocket, decided to go, that he would do it without his wallet and walk quickly to get to the movie on time. Let's take a look here. It says here he started heading back. He didn't go all the way home. So it might be like this one right here. He kind of walked. Then he started walking back home. But he found, over here, he found the $20. Then he walked quickly to the movie to get there on time. Okay, I can see it would be like this one. He didn't go back home all the way like this one here. But he did go in the direction of his home, so the distance from his home is going less. And quickly walk to get to the movie on time, okay? So this one would be 7. And how about number 8? Let's take a look. This graph makes no sense. How can Kyahi possibly move farther from home without any time elapsing. No time elapsing, it means that it would be a vertical line. If you have no time elapsing, because here's the time, that's no time elapsing. From here to here, there's no time elapsing. So how could he go farther from home without time elapsing? You know, distance, traveling a distance, it does take time. No matter how quick you can get there, it still does take time. So I believe number 8 is referring to this chart right here. Well, let's mark it. Okay, moving on. Let's see. Hope everybody got this. You see all my codes here. 2173568 Now see if it really makes sense to you. Go over it. Read these descriptions over here on his journey, and then really try to validate what you see on the graphs, and if it makes sense to you. Okay? And if not, we can always discuss it in class. Okay? But just go over that and take your time and really try to understand what's going on with the description and with the graph. Okay? Okay, next page. We're on page 43. Let me adjust this a little bit. Okay. So the following graph shows Mehana's distance from her home on Sunday afternoon travels as she sets out to walk at noon to meet a friend. Okay. Where was Mehana at noon? The following graph shows Mehana's distance from her home on Sunday afternoon travels. So as I take a look at this graph, it's not real obvious, but I'm going to assume that Mehana is at home, our starting point, which is right there. Okay. Maybe I should use a pen. Okay, is that better? Okay. And what else can we say? Approximately when was Mehana farthest from home? Let's see, that looks like about here. This is the distance from home. So at what time, approximately when, was Mehana farthest from home? Would be this point right here. And the corresponding time is 2 hours. Okay, so let's put that down. 2 p.m. Okay. And we're moving on to the next question. What is the farthest Mehana traveled from home? Oh, that would be that time right there, which is 3 miles, 3.5 miles. Huh? 3.5 miles. Okay. Next one. How far from home was Mehana at 2:30 p.m.? Right there. This is 2:30. How far? 2.5 miles. Okay. See how simple this is? This is not even calculating. This is just reading graphs. For some of you, this is going to be real easy. So approximately, when was Mehana 1 mile from home? 1 mile from home. Okay, this is the 1 mile chart. Now if I go across this graph here, I see here's one intersecting point of the 1 mile distance. Here's another one. So there's two time slots that Mehana is 1 mile from home. The first one is half a mile, or let's say called 0.5, and 3.5. You see that there? That's 3.5. So from 1 mile from home, there's two slots, 0.5 and 3.5 right there. I'm sorry, this is ours. So this point here would be 12:30 p.m. This one here, 3:30 p.m. Okay. Okay, question. When did Mehana return home? At what time did she get there? Well, it looks like 4:30 right there. 1, 2, 3, 4. 4:30 she came back home. Distance from home is 0. That looks like 4:30 to me. Okay. The last one. Describe what Mehana might be doing between 1 and 1:30 p.m. 1 and 1:30 p.m. Okay. 1 and 1:30 p.m. Now here's this horizontal line we saw. Okay? And that says the distance from home is not changing, but time is elapsing by half an hour. So basically, they did not move any further from home at that time. Or Mehana did not. So, well, what could she have been doing for a half hour? Maybe she was at a store. I guess you can drink it. Drinking a smoothie, I guess. Something like that. Okay. Could be stopped at a public restroom and did her business and then moved on from there. Could be anything like that. But she did not increase her distance from her home. All right, that'll be it for the evening. This is a kind of long video, so let me cut it off right here. Remember, you guys got to go all the way to page 53. Page 53. Then we're going to take our little quiz, okay? It's pretty easy. It's all graphing, all about graphs. And you don't need to make too many calculations. It's all about graphs. So have a good evening, and I'll see you tomorrow.